So in this video, we're going to evaluate each expression given the graph of the function. So I have this graph f of x, and I want to evaluate the limit as x approaches -6 from the right. Okay, -6 from the right, so I'm approaching -6 from the right. So what is this going to? It looks like it's going to 4. Okay. The next one is the limit as x approaches -7 from the left. So I have -7. So as I approach -7 from the left side, looks like that's going up to infinity. That does not exist. For right now, we say that this does not exist, okay? It's not a number. All right. Next up, we have the limit as x goes to 10. So this is a regular limit. It's not from the left or the right. As x goes to 10. So as x goes to 10, I need to look from the left and the right also. So how do I do this? Well, I like to use my little handy arrow to help me out. So I'm going to move this little guy around. So it looks like it's heading up to 6 on the right. And then I head up to 6 on the left. So it looks like that this limit exists. And this limit is 6. Now, f of 10. If I plug in a 10 here, if I plug in 10 into my function, it's going to output, looks like 6 also. It's not always the case that the function output equals the limit, but here is a scenario where that is true. Okay, the next one, I'm going to switch to green since this is green, but it's -1. So -1, limit as x goes to -1 from the left, because that's a negative there. And so -1 from the left. So -1 is here, so coming in from the left, it looks like this is going to be 1 here, okay? Now limit as x goes to -1 from the right side. So heading down to -1 from the right, looks like that's going to equal to -1. Ooh. If that's the case, what about the limit as x approaches -1? Well, the only way this limit exists is if the left and the right limits agree, but what do we see right here? The left-handed limit was equal to 1, and the right-handed limit got to be -1. So I'm going to go ahead and take a guess here and say that this limit does not exist, and that is the case. Now, what about f of -1? If I plug a -1 in to my function, it looks like it's going to output where the dot is, the solid dot, not the open one, which is equal to 1. So the function is defined at -1. It equals 1. Okay? Now, the limit as x goes to 2. I'm going to use red here. So it goes to 2 from the right. I see that plus tells me it's from the right side. So here's my 2 here, so I'm going up to 2 from the right. Looks like that limit is 6. Okay, what about 2 from the left side? 2 from the left side, here's 2 here. I'm coming up from the left. It looks like that limit is 2. You can almost think of the limit as the y value in some sense, corresponding here. It's not quite the y value though, and we'll illustrate that in just a second. But f of x, limit as x goes to 2, well, from the left side it goes up here, and from the right side it goes up even higher, okay? So there's this jump between the left and the right hand limit. 1 is 6 and 1 is 2, right? So what does that tell me? That tells me that the limit at x equal to, or as x approaches 2 of the function does not exist. However, the point f of 2, if I plug a 2 in, where does it output? It outputs 4. Okay, so 4 is my output there. So it's not the y value itself, because the y value here, this is an example where the y value of the limit is not equal to the left or the right-handed limit, and the limit itself at 2 does not exist. Okay? Last one here, I'm going to use blue because it uses blue, but it says x goes to 6 from the left. So from the left, as x goes to 6, it looks like it's going to be a y value. Looks like the 2. Okay. Limit as x goes to 6 from the right, it's coming in same way. It's going to also be 2. And then if I take the limit as x goes to 6 from f of x, well, what's the problem? Well, I mean, there may not be a problem, right? If you look at it, it's coming into the same number. Your fingers are meeting up, right? One finger meets up down here at 2, and this finger meets up at 2, so they're meeting up. But the issue is it's not defined at 2. If I plug a 6 in for my function, it has undefined, right? So it's everywhere around 6, but not at 6. But guess what? That doesn't matter when we're talking about limits. All we care about is all of the numbers surrounding in a neighborhood of 6, right? So the limit, your fingers meet up, therefore the limit does exist and the limit is equal to 2. However, if I plug in 6 here into my function, that is going to be undefined. It does not exist. Okay, so there's just a hole there. So that kind of gives you a little bit of a summary. I'm going to back out so you can see the whole thing in one shot. But there you go.